Hi everyone. Let me share with you a dream, an invention. Let me ask you about anti-gravitational motor. Do you think it's a myth? Let me show you in this video that is a reality.
I am here at the University of Sydney where the mechanical engineering shop has built this incredible piece of apparatus for me. It is a 40-pound, that is 19-kilogram flywheel on the end of a meter-long shaft. Can you imagine trying to hold this out horizontally with just one hand at this end? It is impossible, okay? Now I'm gonna let go. You gonna be able to hold this at all?
I hope so.
Can you lift it out? Make it horizontal, hold it. Come on, just try to, I want you to hold it out horizontal. See if you can. Hold it. Oh, come on. What I'm gonna do is I'm going to spin this up to a few thousand RPM, and then I'm going to attempt just that, to hold it from one end and have it out horizontally. Five, four, three, two, one, boom. I'm going to let go with my left hand. What you'll see is that the shaft remains horizontal. You can see it going around there.
It almost looks as though the wheel is weightless. How does this work? Well, instead of pulling the wheel down to the ground as you'd expect, the weight of the wheel creates a torque which pushes it around in a circle. You may recognize this as gyroscopic precession. For a more detailed explanation, click the annotation or the link in the description to see my video on the topic.
To our basic physics theory, you can see two individual formulas, one of the gravitational force that will be used in special only in surface of the Earth, so we can get one simplified formula that depends only on the gravity and the mass, and the other that will be also with us in this video is the centrifugal force that you can see also depends on the mass, angular velocity, and radio. Something very well known is the existence of geostationary satellites that revolve around the Earth in an orbit called geostationary. Because so called? Because the satellite remains still above us. It is therefore necessary that the angular velocity will be the same that the Earth. Thus, only the radius, the height of satellite orbit, can be used in order to balance the centrifugal force with the gravitational force, which are 36 kilometers, having in mind the radius of the Earth. You can compare it with the 10 kilometers height at which airplanes fly. We can see on this example that we take a bucket of water and move it over our head in a circle. We want to prevent that the water falls from it. So we must move very fast, as you can see in calculations, in 1 second, in order to avoid that. Why is this example for? Is to understand that the centrifugal force will help us to overcome gravity. So what is next? Let me present the core of this video, and is the anti-gravitational fundament. Following the previous example, try to imagine the same bucket of water that rotates on an axis, and in the upper part, in the top, will be full, and in the lower part, in the bottom, will be empty. Of course, in the intermediate step, we will fill the bucket or we will empty. But what is important is to make calculations that the centrifugal force will be different on the top and in the bottom. That offers us an opportunity to have a delta of centrifugal force that, if we get, that will be bigger than the gravitational force, we will invent the anti-gravitational motor. Let's do a brief reflection, because we have defined the anti-gravitational formula that is based on different mass in the top side from the bottom side. You can see the balance of this formula in the left side of this presentation. But it's important express another formula in which we have different ratio in the top side from the bottom side. Also, you can see that we will have the same balance, and we will have also the anti-gravitatorio formula. We will use mostly this second case in our prototypes, as you will see, because it's easier to implement. So let's do it. Let's implement it. What do you think? Is it impossible? Let me show you that not. Also very important, follow this presentation, but have in mind that in the last page you will have all the links of this project in order you can have all documents. As we anticipated, our first prototype is based on case 2, different radius. We will move a mass and a small distance depending of its angular position. Our device will be a simple electromagnetic plunger. What do you think? Will it work? We can observe that our estimation is very small displacement of this mass, and also this mass is very small. Also, this is an advantage. The mass of the system will be little. But you can see that if we increase the speed, for example, to 1,800 revolutions by minute, that is equivalent to 30 turns by second, we obtain a very high centrifugal force. Of course, it's not enough, right? But let's do it. Why is so important to try? Because we mustn't forget that if we put 8 plungers in a concentric way, we will multiply this delta force by 8 units. So we will be able to overcome the gravitational force. So we have got it. But it's only when we implemented this system when we discover a problem that wasn't predicted. In the previous example, the failure was the inertia of the mass. The best way to avoid this is with the rotation of another system. Imagine that we can place some motors that we will call inertial motors, and they will rotate a mass as M1 with one arm. The first thing that you will come to mind is that this will produce some eccentricities in the spinning. Don't forget that we can put different motors in a symmetrical way and can spin in reverse direction to compensate these eccentricities. So have in mind that the inertial motors and the traction motors will be synchronized, and we will choose direct or reverse direction to compensate eccentricities. It's important to note that we discarded the option that the inertial motors rotate in the same plane that the traction motors. Don't forget that to avoid eccentricities, we will have to reverse the direction of rotation of some motors. Due to this, if we place in same plane, this will produce a compensation of centrifugal force that will generate a lot of performance issues in our system. To implement this prototype, we have chosen very economical step motors. The reason is because we still didn't know if our invention will be viable, so it's better risk little. This motor has demonstrated to have a serious drawback. Although it has a very high torque because it has a lot of gears that reduce speed, the low speed is the main issue. But anyway, we have keep going with this prototype because we have discovered a lot of new problems in this development. This prototype has allowed to us to advance in the electronic design of the transmitter that, as you can see, we use an ESP32 and some external components like a 5-position microswitch and a small display that allows indicate the speed that we are commanding to the receptor. Also, it's important consider that in the receptor we will have signaling for the inertial motor and for the traction motor. But oops, they must be synchronized. Why don't we use the same signaling for all the 6 motors? Well, in practice, we have some issues connecting in parallel the drivers, and we have to use 2 different sources of signaling to avoid signal attenuation. The first rotation test you have seen that showed us a serious design error. We must avoid eccentricities in the rotation of the system, in special with batteries. Also, it's important to consider that when we send commands to receptor, the SP32 is interrupted and stops the motor. That has been avoided with a functionality included in the Arduino IDE. Is the FreeTOS library that allows in real time 2 processes running simultaneously. You can see our final structure design. This brings us closer to something that is seen with real possibilities. The system doesn't present eccentricities and solves all the previous problems. So it's time to put it work. Let's make previously a small calculation of what will be achieved at 70 RPM. Oops, better don't try. It's a waste of time. Even if we multiply by 4 motors, the centrifugal force will be very slow. So let's go to our prototype 3. We need a light motor with high torque and the highest speed possible. But it's a difficult task with step motors, since force and precision are normally required regardless of weight. We found one which changes the type of winding, is bipolar, and needs, of course, a new driver. But please don't forget that will be needed 6 motors, and the drivers also has to be mounted in parallel to be a synchronized system. Some has to be changed also in our electronic design because the new driver, the A4988, needs to be regulated to the maximum current previously due to internal resistance of step motors is very low, and in order to protect it, that overcurrent has to be limited. One of the main advantages of this driver is that supports digital level of 3 volts. That is what the SP32 gives us. But we are in the right way. We have faster step motors and very good drivers. Testing everything in the sandbox seems that everything works fine. Only 4 engines have been achieved, but the important thing is to keep moving forward. We quickly realized that moving a 9-gram load at a speed above 250 RPM generates torque issues for these engines. As the speed increases, the torque decreases significantly. Bear in mind that we are in case 2. What we are looking is for the variation of the ratio of a mass in the turning system. At a higher speed of the traction system, we also have to move the traction motor at this speed. We get some balance at this speed of 250 RPM. But we quickly come to the conclusion that even though we have gotten closer, is not enough. What is next? I need you for this idea. Go ahead. The theory is good, but the technological solution is not easy. Together, we will surely improve it. There are many ideas to try. The problem, for example, with brushless motors is that they are more difficult to synchronize. But you can try. Any other ideas?